Hi, my name is Karijo and I'm going to present the first lab sticky tape experiment. Starting from introduction, the purpose of this lab is to get to know the charge property of sticky tapes by observations, as well as to calculate the amount of excess charge on a piece of tape by experiment. Some basic physical principles. So objects having opposite signs of charge will attract each other, and on the other hand, if objects have the same sign of charge, they will repel with each other. However, neutral object could always attract any charged object, either positive or negative. And the main equation I use throughout this lab is the Coulomb's law, which is listed as the electric force can be calculated by constant K times Q1 times Q2 over R squared. And since in this lab the upper tape reaches an equilibrium finally, so we can apply the Newton's second law, which means that the electric force experienced by the tape equals to the gravitational experienced by it. Let's look at the U tape. So as we know, if we rub a plastic pen with our hair, the plastic pen will gain negative charge. So if the U tape is positively charged, it will attract the plastic pen. On the other hand, if it's negatively charged, it will repel with the plastic pen. And if it's neutral, it will still attract the plastic pen. And my U tape turned out to be positively charged since it has attraction with the plastic pen. And here are some photo footage of me during this lab. As we can see from the photo on the right side, the upper tape eventually reaches an equilibrium state by floating in the air. Here are some lab data. So the separation between the two tapes is about 0.021 meters. The length of the tape is about 0.31 meter, and the mass of the tape can also be calculated. Here's my calculation steps. I post a screenshot of my code on the right side, but it's basically the same as the left side calculation. So we need to first calculate the gravitational force, and we know the constant K. As I mentioned, the tape was in the equilibrium state, so the electric force is equal to the gravitational force. We also have the assumption that the charge of the two tapes are the same, so we can get the equation of how to calculate the excess charge on the tape B, which is the upper side tape, and we can plug in all the variables we already know so we can get the charge. And since we know the charge of a single electron, we can also get the number of the total excess electron on the tape B. So for the result, I get that the excess charge is about 1.22 times 10 to the negative 8 coulomb, and the number of excess electrons on that tape is about 7.63 times 10 to the 10. And showing by the diagram, the two white particles represents the two tapes, since we have assumed that the charge of the both tapes are concentrated in the center of the tape. And the red arrow represents the electric force experienced by the upper tape, and the blue arrow on the other hand express the gravitational force experienced by it. They have the same magnitude but opposite direction. The calculation continues. So we can get the number of total atoms on that tape, and we can calculate the ratio of number of excess electrons versus the number of total atoms, and it turns out to be 24.6. So here's the conclusion part. This lab helps us to visualize the concepts related to the electric force. Especially, we know that if the two tapes are oppositely charged, they have an attraction force between them, and on the other hand, if they have the same charge sign, they will repel with each other. And we also get to know Newton's second law in this case. since the gravitational force and the electric force experienced by the upper tape have the same magnitude but the opposite direction, because the tape eventually reaches an equilibrium state. And we also understand thoroughly how to calculate the amount of excess charge as well as the number of electrons by applying Coulomb's law. So that's it.